All right, guys. Hey, today we're going to be covering. I'm going to turn down that exposure real quick. There we go. That's better. I can see now. All right, we're going to be covering now section 1.2. Okay, which is the transformation rules. Okay. Just like anything in mathematics, there are rules that we need to follow when we do things, just like order of operations, just like with balancing sides, such as the equal sign, fractions, who comes first, who comes second. It's everywhere, guys. Doesn't go away. So for this one, for transformation rules, a transformation that preserves size and shape is called, you should have remember this from section 1.1, a rigid transformation. Okay, we use the word, I think, rigid motion, if you recall unit 1.1. But the idea here is the same in regards to it being a solid movement, okay? Or an isometry. Okay, if you guys remember that word from also 1.1 when we were talking about the definition of translation, right? Now, there are 4 types of isometries. And they are translation, as we covered in the last video, reflection, rotation, and glide reflection. Okay? And much like translation, where it had that slang term we used for it, which is called slide, there are other words that are more familiar. Right? Those words for these motions. And those words are slide, turn, and flip. Okay? Now, the next one you need to think about here is a dilation / constriction. Okay? Now, dilation / constrictions are 2 other forms of transformations. Sorry, that's transformation. Let's cram that word down there. These are similar but not congruent figures. Therefore, they are not isometric. Okay, very important that you understand that. That's the only one really out of the 4 that does not apply. Okay. Another thing to keep in mind is that the translation is the simplest type of isometry. And finally, all points in the original figure are equidistant. Okay, now that's just basically a fancy term to say that all the things are the same distance. Okay? Right? If you remember our shape from yesterday, in fact, I've got it right here. Okay? All of these points are equidistant from all of these points, right? In terms of t is equidistant from this t, t is equidistant from this t. Z is let me come again. Z is equidistant. I cannot speak. E is equivalent distant or equal distant from this z. So z prime and z, t prime and t, and b prime. So the idea is that all these points for this shape are equidistant from these points. Okay. Apologies. Try saying that word 5 times fast. Okay, equidistant image. Or images, sorry. Images. Defined by a distance and a direction. They can be represented on a coordinate grid by using an ordered pair value. All right, and that's it for that section. Now, what I want you to do is I want you to, on the bottom of that page, put down algebra rules. And as you go through my other videos, I want you to make sure that you record the algebra rules for translations, reflections, rotations, and dilations. Now, you already got the one for translations, if you remember from the last video, which was xy becomes x plus or minus pound sign and y plus or minus the pound sign. Okay? And there you go. All right. Hopefully you guys found that useful. Again, apologies for my stuttering with the word equidistant, but that word is a mouthful. I apologize. Hopefully you got a good laugh out of it at least. Make sure that you review your stuff from Unit 1.1, and remember to refer back to this page while you complete the other sections of the notes so you can record those other rules so you have a nice one page of all the transformation rules right where you need them. All right, guys, have a good time studying, and I'll see you guys in the next one.